starts from 00, and usually the RAM will be addressed in 8 bits. The RAM will be addressed in 8 bits. And let me okay. RAM is addressed in 8 bits, and the structure of the RAM here 128 bytes. So the address will be starting from 128 byte is equivalent to 80H, but you will be having, if I'm representing, you will be representing from 00, so it will be 7FH, the last thing. Okay. So the RAM will be of this type, starting from 00 to 7FH. Each line of RAM, assume that that's memory as a page of a notebook. Each line of RAM can store 8 bits, which is nothing but a byte. Okay. The structure of the RAM will be having 4 register banks. Each register bank 0, register bank 1, 2 and 3. Each register bank will be having 8 registers. Starting from R0 to R7. So the address range from 00 to 07. 00 to 07 will be having for register bank 0. And the first line, namely 00, is for register R0. And register R2, R3 as such. See here, 00 to 07, that is register bank. Each register bank in turn it will be having 8 registers. Each register bank in turn will be having 8 registers. Namely from 01, 00, 01, 02, 03, 04, 05, 06, 07 forms your register from R0 to R7. Namely 00H is for R0, 001 for R1, 02 for R2. Like that, the register bank R0 is classified into 8 registers starting from R0 to R7. So from 00 line of memory to 07 line of memory, will be having register R0 to R7 of register bank R0. And keep in mind, each line of memory can store a byte or a 8 bits. Okay. So 4 register banks, so 4 into 8, so 32 registers you will be having starting from 00 to starting from 00 to okay, starting from 00 to 1FH, this one. Okay, 1FH. So, and the next 16 bits, 16 bytes, I'm sorry, the next 16 bytes from 20 to 2FH, each byte or each line of the memory can, that each bit can be individually accessed. So, each bit will be individually addressed also. Only if we have an address, we can pick the data. Okay. Now, for example, if you receive a postal cover from the post office, only if the address is clearly written, it will reach you. Similarly, here each bit is individually addressed because these are bit addressable memory location. Why it is individually addressed? Each bit can be easily accessed. It is individually bit addressable. So this bit address will be 00, 01, 02, 03, 04, 05, 06 until 7F. The 16 bytes are 3-bit memory location. The rest of the memory portion from 30 to 7F, it is general purpose memory. It is general purpose memory that can be used for a stack, used as a stack, and it will be decided from by the user that which portion of the general purpose RAM can be used as a stack. And the next half, this is your special function registers. It is similarly addressed as like the general purpose RAM, and it will look as a general purpose RAM, but this is the additional special function registers. But as of the internal memory of RAM is 128 bytes only, 0 to 7F. This is the special function register. It is addressed in 8 bits as like your RAM, and it will be similar to your RAM memory location, starting from 80 to FFH. Starting from 80 to FFH, here you will be having your ports, data pointer register, timer register, serial buffer register, accumulator, other registers you will be having. Okay, and here also some of the registers are bit addressable. See here the P0, TCON, P1, SCON, and SCON is serial control register, and interrupt enable, port P2, and interrupt prior. Each register will be having an address. Instead of writing it as P0, I can even tell 80H. That is indirectly does it means that I am telling P0. I'm going to move about P0, or I deal with. Okay. So here the address range I have written. So the register bank R0 starts from 0809 A, B, C, D, E, and F. So R1 is 08 to 0FH, and R2 is from 10, 11, 12, 13, 15, 16, so 10 to 17H, and R3 is from 18 to 1FH. Keep everything in hexadecimal address I have written. And R3 register bank, R0 to R7 again, ranging from A 1F. Okay. So 1F plus 1, that will be equal to 20. 20 from 2FH. The next is 16 bit is bit addressable memory location. As I said, from each bit can be individually accessed. So each bit will be given an address. Okay. And 30 to 3F, 7FH is a general purpose RAM, and you can use it as a stack portion of the, depending on the user, which portion of the memory, general purpose memory, that we are going to use it as a stack. Opposite, stack pointer, stack pointer register upon reset, the default value is 07. Similarly, upon reset, the default address register bank, the register bank is reset. Upon reset, automatically your program counter will be pointing out your register bank 0. And always when you are dealing with, if you are not specifying anything, you will be dealing with only the register bank 0, unless and until you tell that move the data in the register bank 1, 2, or 3. Automatically, if you give register bank R0, it will be stored only in the register bank 0. Special function register or special internal registers, as I said already, from 80 to FFH, you'll be having your special function registers. And coming to your RAM memory, as I said, you have register bank 0, 1, 2, and 3 from 00 to 1FH, 16-bit addressable registers, 16 byte memory locations, individually addressed bit addressable memory locations 1F to 2F, and 80 free registers. Each register can 8-bit, or each line of the memory can store at 8. And special function can be addressed by direct addressing. That and all I'll tell what is mean by direct addressing. And plus you'll be having 128 bytes of free locations that can be. And coming to your memory, ROM memory, in inbuilt memory, you can have 4K bytes of ROM that we need. 51 will be having 4K bytes of ROM, 4 kilobytes of ROM. Okay. Address bus or as I say, this um, 8050, as if I say it's an 8-bit microcontroller, meaning it can process 8 data bits at a time. Okay, so I can tell It's an 8-bit microcontroller, and it has 16 address bus lines. Okay. So 16-bit address lines, meaning it can address from 0000H from FFF till FFFH. Okay. 0000H FFFF. So FFFH, okay, we can 65534, meaning 6.5K, it can address 65K. Okay, so this many memory location, convert this FFFH to decimal. Okay, I'll be getting 65534, and this might decimal plus 1 it will be. Okay, address up to 00002 FFFH, and your internal RAM is of 4K only. Okay, it's a 4K only, starting from 0000. It can address 0 triple FH, around 4000 kilobytes. Okay, 4000 kilobytes. See, from the rest of the bytes, that is one. We are using this here. This is said to be external access. If I'm using EA pin as 1, I'll be using an additional ROM memory. Additional memory. If I'm using EA pin as 0, only if it is grounded, connected externally. This is connected externally. It is 4K. The address range is from 00 to 3FH. So 4K is 4000. 4000 decimal converted into hex. 0 is 0. 0 F A 0 minus 1. 0 F9 FH. Okay. This address range, see, but we have only 4000 kilobytes here internally that is being present. Internally, that this is the ROM that is being present, but the capacity of address line, it can address from 00000 to all FH. That is what I mean to say. I can add external memory. Okay, I can add external memory because it can address from 0000 to 0. I mean, FH. Is it clear what am I telling? Could you able to get me?
Ma'am, can you explain it again?
See, we have 16 bytes of 16 bits of address line. If you go ahead with your pin diagram, the port P0 and P2 is used for address, and provided P0 is a multiplexed address and data bus, meaning sometime it will act as an data bus, for some time it will act as an address bus. So address bits is from A0 to A15, 16 bits of address lines we have. Data bus is only 8 bits, as 8051 is an 8-bit process, microcontroller. It can process 8 bits of data at a time. So I'm telling that it's having 16 bit of address line, so it can address from 0000H to all FH. Okay, the address lines, because the 0000H is nothing but 0000, 0000, and 0000, and This is equivalent to 000H. Okay, from all 0 to all 1 we can address, but we inbuilt is 4K only. Okay, inbuilt is 4K only. Okay, 4000 kilobyte of internal RAM, right? 4K only, but we can address up to 64 kilobytes of memory. Okay, 0000 to all FH is nothing but 64 kilobytes of memory. Okay, this is nothing but address rate 64K. Whereas this 4K can be addressed from 0000 to 0FFH. So this is only 0. Namely from 1 followed by 00 till all FH we can even address. We have that capacity, but the internal RAM is only 4K. If I am not sufficient with this 4K bytes, I can put an external RAM. I can connect an external RAM. Okay. Is it clear? So how to connect that external RAM? Like we have an external access pin in the pin diagram. External access pin in the pin diagram, EA pin will be 0. If EA pin is 0, we are going to access that and all we need to give it in the program. We are going to access the external memory. Okay. If EA is 1, we are going to access the additional memory. If some more memory, we are going to place it inside the chip itself. Without the additional memory, that will be accessed. But for accessing your external memory, you need to make your EA pin 0. EA pin, external access pin, pin number 31. Okay. This is about your memory. On the pin diagram, you know, 4 ports you have. Each port is 8 bits. Reset pin, ground pin, external access pin. ALE is arithmetic latch, address latch enable. Address latch enable. Whenever this address latch pin is 1, whenever this ALE is whatever data that is present in the port P0, in the port P0 is the address, meaning A0 to A7. If this ALE is low, meaning if ALE is 0, whatever data that is present in the P0 port is the data. This is program store enable, that and all I will tell when we are using it. Okay. Okay. So the next thing we are going to see is about your, I'll just go ahead with the instructions. The ports. Okay. So the instruction sets, I'll just go ahead directly with the instruction set. I'll deal separately with the timer and serial communication ports, everything. Instruction set. So to do the program, the designer will be having or whoever designed 8051, the design engineer have a set of instructions that be performed in your 8051. Those instructions are, number 1 is said to be data transfer instruction. Number 2 is said to be arithmetic instructions. Number 3 is said to be logical instructions. Okay. And jump and call instruction, otherwise said to be, you can say that okay. I'm telling an instruction. Instruction is nothing but you need to instruct 8051 microcontroller what it has to do. You need to write the program. So an instruction is otherwise said to be a mnemonic. The mnemonic, you have two parts. One is opcode, another one is operand. Okay. Opcode is otherwise said to be operational code. Opcode is otherwise said to be operational code. Operand is said to be, okay, opcode is said to be operational code. The data, okay, operand is said to be the, and see this and all is said to be, each microcontroller will be having its assembly level instructions, whereas high level instruction is nothing but you will be writing code in embedded C or C++, and that will be by using a compiler you can convert that C language into the assembly level code or the mnemonic code, and then you can compile in the 8051 microcontroller. That is possible here. So the assembly code and the operand. Okay, so based on this opcode and the operand, the instruction may be a single byte instruction, 2-byte instruction, 3-byte instruction, 4-byte instruction. If an instruction occupies only one line of memory, we know that assume I have asked you to assume that it is nothing but pages of a notebook. Each line of memory can store a byte. Each line of memory can store a byte, and this byte, for example, if it's a single byte instruction, okay, and namely increment, I'm using INC, okay, increment A, increment the content available in the A register. Okay, by 1, it will be incremented by 1. So INC1, this will occupy a byte. If in the memory, in the code portion of the memory or in the RAM portion of the memory, if in the memory the instruction is a byte of memory location, that those instructions are said to be single byte instruction. If the instruction occupies 2 bytes of memory location, then it is 2 byte. And if it occupies 3 bytes of memory location, if it is said to be 3 bytes, 3 byte instruction, and so on. Okay. Now, for any instruction, as I said, you will be having two portions. One is opcode and another one is operand. The simple instruction that I'll tell is opcode is nothing but operational code. It is going to instruct the microcontroller what operation it has to do. For example, move A comma B, meaning move the content of B into A register. Move is said to be the opcode. Similarly, INCA, increment your content by 1, the register content A by 1. So this is your opcode. Opcode is otherwise said to be operational code. Now, to operate with, I'm telling opcode, operational code has to operate on the data. So the operational code has to be operated on the data. Okay, we need data. So where the data is going to reside? Either it is placed inside the memory, or it is placed in the registers, or your in the memory means either in the internal memory your data is placed, or in the external memory your data directly as a part of the instruction. Okay, so the way in which that we are going to access the data is said to be the way in which we are going to access the data for an instruction is said to be addressing modes. So the addressing modes is classified into four types. Yeah. Number 2 is register addressing mode. Number 3 is direct addressing mode. Number 4 is indirect addressing mode. Okay. With the data transfer itself, I'll tell you the different types of addressing modes. Right. So the data transfer instructions, the first classification of instruction is data transfer instruction. So the data transfer instructions are classified into move instruction, move X, move C. Okay, move X is external, move C is related to the ROM, move code memory. ROM read only memory is nothing but your code memory. Number 2 is push and pop related to stack. Number 3 is exchange. Okay, these are the data transfer instructions. I'll tell you with example. Okay, coming to move. First one is your immediate addressing mode. What is that immediate addressing mode? If data is the part of the instruction, then it is said to be, if data is the part of the instruction, then it is said to be immediate addressing mode. Move A, hash 08H. This is going to be the data. This is going to be part of the instruction. Data is a part of the instruction. See, one of the operand is the data itself, directly displaced in the instruction itself. And usually the data will be represented by the ampersand symbol or hash symbol or pound symbol, whatever. Okay. If the data is directly specified as a part of the instruction, and usually the data will be represented by the pound symbol, meaning if pound symbol is followed by a number, meaning this is the data and this will be transferred to A. See, in your Keil microcontroller, if your second data is F0H, it cannot understand your alphabet. So you need to represent it by 0, preceded by a 0. Only then your compiler can understand that this is a data. Okay, 0F0H, if this is an alphabet that is going to be the first number. So this and all is said to be immediate addressing mode, where the data is a part of the instruction. And now the register addressing. The register mode is nothing but move A, comma B. The data resides in the register. That is register addressing. Data resides in the register. Okay. So let me assume that B is having 33 heads. After executing this instruction, A will also be the address of the data as a part of the instruction. Okay. We're going to specify tell the address of data as a part of the instruction. Okay. For example, move A, 80H. See, the address won't be specified by the pound signal, pound symbol. Only the data will be specified by the pound symbol. Address will be directly given. What is the meaning of this is 80H, the address line 80H. What is 80H? Do you remember 80H? Guys, do you remember 80H?
Ma'am, register.
What is 80H? What is this?
128.
Yeah. Look into the diagram and tell me what is this. 80 is representing what register? The line 80 is meant for which? P0 means port P0. You have 4 input output ports, right? Could be able to see this? 80 is nothing but P0. You're getting me? What am I telling?
Yes, ma'am.
So 80H is nothing but port P0. Meaning whatever data available in P0, transfer that to A. And we know that each port is of 8 bits, starting from P0 0 to P0 7. Each bit can be individually accessed. So let me assume that the port pin is having 33 FH. So after executing this instruction, A will be having 3 FH. Okay? Is it okay? And move 3A, comma, hash 3B. What is the meaning of this instruction? If I am representing by a hash symbol, what is this?
Immediate address.
This is a data. So this has to be transferred to this. This is not being represented by an hash. So what is this? What is this?
Location, ma'am.
Memory location. So after executing this instruction, what is this? The memory location 3A will be having what?
3B, ma'am.
Huh?
3B as data.
Yeah, 3DS data. This is said to be direct addressing mode. Okay, some of the examples of direct addressing mode. And move R0, comma 12H. What is R0 register? Where it is available?
And 002.
R0 is available in bank 0. Am I right? Default memory location is 00. This is R0 actually. 00 is R0. So after executing this instruction, 00H will be having what? And then what is the meaning of this instruction? It is not this 12 is not represented by a pound symbol. So what is the meaning?
It is the address.
It is the address. So let me assume that the 12H is having a F3H. Okay. Huh? After executing this instruction, whatever data that resides in 12H, move that to R0. That is the meaning. What is the data available in 12H?
F3H, ma'am.
F3H. F3 has to be moved to R0. What is R0? R0 is 00. So this will be having F3. Is it clear?
Yes, ma'am.
Okay. Next one is indirect addressing mode. Instead of giving directly the data, I'm going to give the address of the data as a part of the instruction. Okay. I'm going to give the address of the data as a part of the instruction. That is said to be indirect addressing mode. Right. So I will be using a data pointer. This is instruction. You will be having this instruction. I'm having a data pointer. So move 50, comma at the rate of R0. What is the meaning? Tell me, guys. Here, R0 is used as a data pointer, meaning have an address. What is R0 by the way? By default, R0 is available in register bank 0. It is in 00H. Let me have in 00, let me have 3E. Okay. So 3E, let me have 3E. So R0 is having 3E. This is R0. This is the address for us now. A data pointer, meaning this is the address. It is going to point the address of the data. This is the address of the data. So somewhere in 3 memory location, I am having the data. Let me have 46H. And what is this, by the way? This 50 is an address of the data. This 50 is the address or the data? It is the address,
Address,
right? Yeah. So 50, let me have somewhere 50. Okay. Whatever data that is pointed out by R0, that should be transferred to 50. What is the data that is pointed out by R0? What
Three,
is the data
three,
that is pointed out by R0?
3E.
3E.
That is not the data, no? What is the data? Get my
46.
question clearly. What is the data that is pointed out by R0?
46.
46.
46. This is going to be the data pointer, meaning pointing the data. So 46 has to be transferred to where? Memory
50.
location
51.
50. 46 will be transferred to memory location 50. Okay. Now move at the rate of R1, comma, hash 40. Now tell me, let me ask you, what is this R1 by the way? What is this R1? What is the address of this R1?
01.
7, ma'am. 07.
01. Let me assume that the R1 is having 2, 2. Okay. R1 is having 2, 2. Now tell me what is the meaning of this instruction. And 40H is having somewhere, means 40H is having FA. Okay, this is the data, right? Okay, I'm sorry. What is this? This is the data. Immediate operator. Am I right?
Yes,
This
ma'am.
is the data. Hmm? This data has to be moved to the address as pointed out by R1. What is that that R1 is pointing?
2,
22.
ma'am.
So in 22, what we need to place?
40H.
40H.
Is it clear?
Yes, ma'am.
And keep only registers R0 and R1 can be used for indirect addressing. Other register can't be used. That is a restriction here. Okay. Only these register can be used as a data pointer. Are you clear with the 4 type of addressing modes?
Yes, ma'am.
Okay. Next one is external data mode. As I said, the address line is 16-bit, so you can address from 0000H to FFFH, but we have only 4K bytes of ROM and 128 bytes of RAM internally. If this memory is not sufficient, you can go for external memory. You can add external memory and you can use it. So for accessing external memory, if you are using any external memory for addressing those external memory, we are having this external memory move instructions. Okay. This external memory can be of two memory. Either it can be a code memory or it can be a random access memory. Okay. Mm. Mm. Let me come with an example. Move X. Okay, X represents your external move. Okay, X represent if an X is added to the move, okay, the mnemonic move, the data move is external to the 8051, meaning, I'm sorry, the data move is external to the 8051. So, example, move at the rate of DPTR. DPTR is a data pointer register. It's a 16-bit register. It's a 16-bit register. Okay. Move DPTR at the rate of DPTR, comma, A. Okay. Okay. So DPTR is a 16-bit register. For example, external RAM location. For example, external RAM from, let me assume that from 0000 from FFFH. I am using an external 64K RAM. Let me assume in the DPTR register, that is, I'm having 1, 2, 3, 4. So in the memory location 1, 2, 3, 4. What is the meaning of this? Whatever data available in A, that has to be placed in the address as pointed out by the data pointer. So let me have A is equal to 12H. So now tell me, after executing this instruction, what does this 1, 2, 3, 4 represents?
Address, ma'am.
What we will be having it in 1, 2, 3, 4?
12H.
12. Now move X, comma, at the rate of R1. Now tell me.
Ma'am, 14 will be stored in A.
14 will be stored in A.
A.
At the end of this instruction, 14 will be there in A. Now, next is your code memory data move. So code memory data move will be represented by move C, meaning ROM memory moves. Move C A, comma, at the rate of A plus PC. PC is said to be program counter register. It's a 16-bit register. It's a 16-bit register. What is the meaning is, let me assume that program counter is having 1F, 1F. Okay. Accumulator is having 1, 1. What is given? Add accumulator program counter first. So 1, 1, 0, 0, 0, 1, 1, 1, 1, 1, 0, 0, 0, 1, 1, 1, 1, 1, and 0, 0, 0, 1, 0, 0, 0, 1. Take care of my addition here, otherwise I will prompt a mistake. 1, 1, 1. Am I right?
Yes, ma'am.
1F30. Is the memory location right? This is 1, this is F, this is 3, this is 0. Am I right, guys?
1F, 1F.
3, 0. 0, 0, 1, 1 is 3, no?
Yes, ma'am.
So now this A plus PC is nothing but 1F30. Whatever this 1F30 is pointing, whatever data in the that is available externally, move C means external data move. 1F30 is pointing out some data. Let me have 30H. Am I right, guys?
Yes, ma'am. Yes.
Yes, ma'am.
Okay. That data has to be moved to
A.
A, ma'am.
So which has to be moved to A now? A will be having
30H.
38.
is it right? Whatever data that this is pointing. This is an address again, no?
Oh,
Yes,
yes,
ma'am.
ma'am. This is the address.
So 30H will be whatever that 30H is having, that will be moved to A. It's an 8-bit. Okay. This we will do it as a program and check. Okay. As of now, you just remember these opcodes. Okay. I mean mnemonics. External data moves. Shall I stop with this? We'll go ahead with push pop and exchange in the next class.
Okay, ma'am.
Okay, ma'am.
Up to this, is it clear?
Yes, ma'am.
Yes, ma'am.
Right, I'll stop the recording.